and welcome back, and in this video we're going to continue solving quadratic inequalities. Now if you haven't watched the first video, make sure you go back and do that. This is just going to be a couple more problems to be a little bit to give us just a little bit more practice. So let's jump right into a problem. We have 3x squared minus x minus 10 is greater than or equal to 0. Make sure everything's on one side of the inequality. We have that. Check for a greatest common factor. We don't have one, so we go straight into factoring. So I'm going to go ahead and factor this. All right, so I went ahead and factored and got 3x plus 5 and x minus 2. So that gives me two zeros of negative 5/3 and positive 2. But remember, we are solving an inequality, so what we need to do is place these on a number line. So that's what we're going to go ahead and do. So we have them on a number line here. We got our sign table set up. So now we're going to go ahead and test out some values. So I'm going to test any value that's less than negative 5/3, something like negative 10. And if I plug negative 10 in for x, both of these factors would end up being negative, but when they multiply together, that would end up becoming a positive. So that means this interval here is positive. Then I could go ahead and test some number in between negative 5/3 and 2, something like 0. If I plug in 0, 3x plus 5 would end up being positive, but x minus 2 would be negative. And a positive times a negative is a negative, so that entire interval here would be negative. Then if I test some number larger than 2, something like 10, 3x plus 5, well, if I plug in 10 for x, that would be positive. Same if I plugged in 10 for x and x minus 2. So when I have two positive factors multiplying, they give me a positive factor. So that means this interval here is positive. Now remember, we want it to be greater than or equal to 0. So that means we wanted to be positive, a positive number. Well, that happens in two specific intervals. It happens in this interval here and this interval here. So we are positive from negative infinity all the way up to negative 5/3, and it is or equal to, so I can include negative 5/3, or from positive 2, and once again, I was or equal to, so I can include 2, and it goes from 2 all the way to positive infinity. So that would end up being our answer for this particular example. Now you should notice somewhat of a pattern emerge in here, and it is a pattern that stays true most of the time, but there are some special cases where we don't see this plus minus plus, and we're going to take a look at an example of that now. So let's say we had this example here. We have x squared plus 12x plus 36. Well, let's go straight into factoring because I have everything on one side and there is not a greatest common factor. So I would go straight into factoring. So in this particular example, this is actually a special trinomial. This is what we call a perfect square trinomial. And the reason it's a perfect square trinomial is because we end up getting the same factor twice, x plus 6 and x plus 6. Another way you can write x plus 6 times x plus 6 is x plus 6 quantity squared. So this was another way that you could end up writing it. And that's what I mean by a perfect square trinomial, because it becomes a binomial squared. So in this example, it's just a little bit different because we actually only have one particular x-intercept, 1, 0, and that would be negative 6. So all we would end up putting on a number line is negative 6. So in this example, since we only have 1, 0 of negative 6, there's actually only two intervals to check, below negative 6 and above negative 6. So if I test any number that's less than negative 6, something like negative 10, if I plug negative 10 in for x, well, negative 10 plus 6 would end up being negative. Same thing here. A negative times a negative would be a positive, so this would end up being positive. And if I test some number larger than negative 6, something like 0, both of these intervals or both of these factors would be positive, which means it would multiply to a positive. So what we end up having here is this particular instance. And now what this was asking for is it to be less than 0, which means we want it to be a negative interval. However, that never happens. It's always positive. So what this would be is actually no solution. This would actually end up being a no solution. So you do have special instances when you have the same factor occurring more than once, and that is going to be something that you need to be aware of. Now, just to play devil's advocate here, what if this was less than or equal to 0? What if this was less than or equal to 0? Well, then we still want to be negative, but we would fill in -6, which means -6 would actually be the only answer. So that would actually be the only answer. And in interval notation, we would just put -6 in those kind of curly braces, and that would be our final answer. All right. Now, these are special cases. If this was greater than or equal to 0, we would want to be positive and include -6, and that would actually be all real numbers. So we need to be very, very careful when we have these special circumstances. My suggestion is to always fill out the sign table, do it step by step, and make sure that you get the correct answer. Some of you guys will notice some patterns, and if you feel very comfortable with those patterns, feel free to use them, but just know that there are some different circumstances that can arise. So be very, very careful when we are solving inequalities. I hope this video was helpful. This was just a couple of extra problems. If you still have questions, please feel free to reach out and let me know. And I look forward to seeing you guys in the next video.